today we will have a workshop about Mage. You probably, I hope, have seen another workshop we did with with Tommy. When was it? 2, 3 months ago? Two, I guess. We did not manage to cover everything we wanted to cover on that workshop, and one thing was DBT. And I think today this is what we want to talk about partly, right? So we will, at least I remember seeing DBT in the description. So I will probably shut up now, and Matt, you should take over.
Awesome. Thanks, Alexi. Yeah, I'm super excited to talk about it. I'll share my screen right and we can jump right in. Yeah, today I'm going to talk about making data magical and how you can level up your transformation with Mage. This is something that's super exciting to me. We'll talk a little bit about Mage, talk a little bit about the modern data stack generally, and where we see it now, where it's headed, and then, of course, save time for our workshop. I'll hide this here. So I guess first, a bit about me. Currently work in DevRel and other things at Mage, but previously worked in analytics engineering, product analytics, and data engineering at a few different places. I also enjoy staying active, and I moonlight as a cactus there. So anybody else that likes cactuses, feel free to reach out. But I'm sure you're all wondering, if you haven't seen the other workshop, right? What is Mage? Well, Mage is an open source pipeline tool for transforming and integrating data. It's a really design first tool. We take a lot of software engineering best practices and bring them to data transformation. You can kind of see that from the screenshot there on the right. And we're going to talk more about that later. But first, we're going to talk about where data transformation is today as kind of a little lead in. Right, if you've worked in data for any amount of time, I'm sure you've noticed that this term, the modern data stack, which we use to describe that sort of umbrella of tools, is evolving. And really the sophistication has been built on the data community, right? A lot of these changes, a lot of these tools that we use today are open source tools, which are really cool, right? DBT Core is an open source tool, Airflow is an open source tool. And if you think back even a few years ago to what these tools looked like, there's been a ton of progress. I have listed here, what did dynamic tasks in Airflow look like a few years ago? Well, they didn't exist because I remember building like a framework for dynamic task generation before it was integrated into Airflow. Obviously, they did it a lot better than I did. But what that means is that more problems are now solved problems, right? And if we think about how many truly novel problems we're solving on a day-to-day basis as data engineers, that number is far less than it used to be, right? Often we're taking maybe something that's unique to our situation, breaking it down into distinct steps, and then going out and finding examples of how others have solved those steps, maybe on like Stack Overflow, maybe using ChatGPT, something like that. And with these solved problems, processes are improving. A few examples here, dbt clone, a new command that didn't exist up until a few months ago with dbt 1.6. That's another framework or another solution that you used to have to build from scratch. And SQL Mesh is a tool similar to dbt that brings a lot of these new functionalities to SQL orchestration and transformation. So I think really we are seeing an evolution in the modern data stack, which is exciting. But I want to call out that not all modern data stack really advancement is equal. So if we think about the different sort of categories here, visualization and BI. A lot of tools in visualization and BI, Looker, Tableau, right? These have been around for decades, actually. And there are lots of options if you're going to go down the BI route. Now, don't get me wrong, there are still companies that are innovating here, but it's sort of, I would say, more of a solved problem than other components of the modern data stack. Data storage and processing has come a long way. Snowflake, Databricks, even if they can't stop arguing, they do both have really good products, and they've both grown tremendously in the past few years. Data integration, I think that's another area that we could see a lot of improvement, but we do have Fivetran. Mage does data integration as well, as we'll see. And solutions like Meltano, Airbyte, these other competitors that are kind of paving the way. But I think orchestration and transformation specifically still has a long way to go. And we see that with things like dbt, shortcomings there, things like Airflow, a lot of struggles that practitioners face every day just developing with Airflow, et cetera. And I think that's reflected by the fact that Airflow still has an adoption chart, a GitHub star history that's up and to the right, despite the fact that it's existed for close to 10 years at this point. And so I see tools as falling into one of two categories, either imperative or declarative. So imperative tools define operations. Airflow and dbt are good examples where you're writing code specifically, like you open up a new Airflow DAG and you're coding exactly what you want to happen in each task in Python. And that's good for some things. It's bad for others, as we'll discuss. Declarative tools are the opposite. They define outcomes. So maybe you open up Fivetran and you say, I want to take my data from the cloud somewhere, S3, and move it to Postgres. I want to take my data from HubSpot and move it to BigQuery, whatever, right? You're not writing code, you're just telling the tool what to do. So it's a case of minimal versus maximal abstraction. And each has its drawbacks, right? Imperative tools are expensive to maintain and build. They might be free, but building Airflow from scratch and building dbt from scratch can be a nightmare. And you can introduce a ton of tech debt, which also has a cost, right, into your code base if you're not very smart about what you're doing with those tools. Now, declarative tools are often pretty rigid and sometimes just plain expensive, right? So you want to change the way Fivetran does something, well, you're gonna have to send an email to your sales rep and hope they can figure something out. Or, and then at the end of the month, you actually have to pay them, right? So there currently isn't a middle ground, and it results in what I would describe as a non-optimal developer experience. You either have to build everything from scratch, or you have to find a solution that's not perfect, but does most of what you're looking for and results in some like hacky workarounds, right? And so this non-optimal data developer experience is a byproduct of shortcomings in the modern data stack. And when I think about developer experience, there are a few components that are kind of agreed upon, and those are flow state. So like, how easy is it for you to get into that zone where you're just writing code, you're making progress, you're building things? Feedback loop, how long does it take from when you make a change until you see a desired result, right? In data, I think it's there are notoriously long feedback loops, right? Like, oh, I spent a ton of time locally testing this thing. There's this screenshot I have here from Matt Martin. He says the easiest way to stop an Airflow local instance is to reboot your computer, right? That's a super long feedback loop if you have to turn off and on your machine just to develop locally. And cognitive load. How much do you need to know to do your job? If you have to open up a Notion doc and walk through this super long development process, a super long contributor guide, right? Like, that's a real hindrance to being able to do things that matter. If you're like me and you're working through these things in a non-optimal developer experience, this might be you at the end of a super long day, right? And so ultimately what we want to do is reduce the time we spend in undifferentiated work. Undifferentiated work being things you just have to do that you don't want to do, maybe, that don't really move the needle on the business, right? We want to do more differentiated work, stuff that drives progress, builds new solutions, allows us to unlock really powerful change in business and create value from data, right? So I think a very valid question is, hey, how is the modern data stack going to change in the future that allows a better data developer or data DevX, right? Does all those things we talked about, reduces feedback loops, and allows us to focus on differentiated work. Well, I'm here to argue that it's hybrid tooling, so not implicit or imperative or declarative tooling, but something in the middle that prioritizes the developer experience. So something that's rigid, yet it has structure. It allows us to edit code, but it's also flexible, and it allows for unique solutions, right? And I think maybe a valid rebuttal is, well, hey, can't we do this ourselves? Can't we take Airflow? Can't we take dbt, these imperative tools that already exist, and then add some structure on top of them to achieve the same outcome? And I would say yes. I think that's a very valid way to go about bringing a hybrid structure to data transformation and moving that part of the modern data stack forward. And there are some good frameworks that actually exist for that, right? If you're familiar with Astronomer, they do pretty great work. They have the Astro SDK. They have Cosmos that lets you run dbt in Astronomer, or in Airflow rather. There are tools like dbt Coves or Paradigm that drop these frameworks on top of existing technologies. But I would argue that the underlying tech there is inherently limited, right? Airflow has this XCOM backend concept. This is was a design decision when Airflow was released because it's an orchestrator, and that sort of just drops a hard limit on what you can actually do with the tool. Similarly, DBT has all sorts of incentives and priorities for development that might not line up with exactly what we're looking for in the open source community. And so that means that these are hindrances to achieving a more optimal data developer experience and to building solutions that are really effective for our use cases. So this is where I talk a little bit about Mage, right? We give data teams power-ups, and I'm here to present Mage as this hybrid solution, as a option for a tool that allows you to do to solve many of the problems that we face in the modern data stack today. And so we're going to get into a demo. I'll just give you a little overview of how Mage addresses these problems, and then we'll go through our workshop. We'll talk about some sample pipelines in Mage. So we have a hybrid environment. So there's a GUI for interactive development, but the great part is that every file exists as code. So you can open up VS Code, edit simultaneously while you're developing your project, right? And then we have this idea of a block as a testable, reusable pieces of code. And that creates this sort of atomic component that you can then reuse throughout your project, which is a fundamental software engineering best practice, right? If you're developing an Airflow and you have duplicate functions, there are the messy calls and code scattered throughout your project, it's super easy to end up with tech debt or spaghetti dags or this weird stuff that can get really hard to debug and develop in parallel. And so, that results in an improved developer experience. We can code, we can test in parallel. I'll show examples of those as well. And you can reduce your dependencies, right? If you're working in less tools, if there's less to worry about, that's the cognitive load piece I discussed earlier, you can be more efficient. So yeah, we have these engineering best practices built in. We're going to talk through all of these. We'll get to the fun stuff here in a second. And, I think maybe a interesting piece there at the bottom, sorry for the acronym, but tools like Mage enable what I call data engineering as a service. And I think that this is super important because, everybody talks about self-service analytics or tools that enable people to go do analytics themselves and unblock analytics teams. They don't necessarily talk about the same for data engineering. But when you have a framework that lets you build reusable pieces of code, you can have your data engineering team really architect patterns that can be implemented by folks that maybe don't know DevOps or don't know about Docker or some other like fundamental deployment technologies, but that understand Python or understand SQL. And so the concept of data engineering as service is like, hey, let's have our engineers go out and build these patterns, these transformations in code, or create templates, and then let analytics engineers, analysts, other folks in the business that want to build data pipelines implement those because they have the power to do so. And that can be really powerful for unblocking your data team. So, of course, this wouldn't be a workshop without a demo, and we'll get started with something simple here. So we're going to start.
And I first want to add, I did not mention, I forgot to mention that you can ask questions in the live chat. So typically for webinars, we have Slido, but here, since it's a workshop, so just ask your questions in the live chat. I see that there is one question already, but I think that question is more like comparison between Mage and another tool. We will probably talk about that at the end.
Awesome.
So I want to make sure we have enough time for all the demos he prepared. So let's take a look.
Cool. Yeah, no, and I don't think they'll be too long. So I did save some time for questions. Hopefully we'll have plenty of time for that. And if you want to follow along, here's a QR code. It's going to link to the repo that I'm pulling this from. And so it's actually a Docker container. Specifically, it's a dev container. I'll talk about what a dev container is. But if you have VS Code, it's super simple. Or if you have Docker installed, it's just a Docker compose up. And we'll talk about that a little bit here. So all of
I just posted
Studio.
the link to the live chat, and I will also add this to the description. And Matt, can you make your VS Code larger? Because that font is super tiny. Maybe
awesome.
hit control. Yeah. Maybe more. If you do this one more time, or maybe 2 times. Yeah, that's readable now.
Okay, cool. Thanks for the heads up. Yeah, I don't know what things look like on your end here, so that's helpful. So this is a dev container, which is basically like Docker environment within VS Code. And I built it this way just because it's very simple. If you're familiar with VS Code, you actually don't need to know much about Docker. And I have a few Mage pipelines preloaded in here. And we'll talk a little bit more in the more complex walkthrough when we get there. But the basic thing you need to know is that you can either run Docker Compose up from this directory, or you can just select rebuild and reopen in container. And VS Code is going to, it reset my zoom there, spin up a Docker network with everything that I defined in this container. So once that's done, I think I should be able to zoom in again. Yeah, cool. And so since this is launched, we should be good to go. So I should, when Mage is running locally, it's accessible at port 6789. So
I just want to make sure I understood what happened. So what he did is run this thing as a dev container, right? And it started Mage inside Docker, right? Right now, it showed this pop-up saying, right now Mage is running here. You click on that link and you have access to Mage, right?
Yeah. Thanks for the clarification. So in this folder, I have a Docker Compose file, and you can see Mage as a service. We also have like a Postgres service so that there's a database to write to. And there are a few other things that are going on that I'll discuss in the more complicated example, but super basic, like that command I ran just runs a Docker network that has our Mage instance and Postgres and a few other things. So at its core, pretty simple, even if it might look a little bit more complex. So thanks for asking that question. It's a good one. So this is Mage. I'll make this big too. So hopefully that's visible to everyone.
It's running in this browser, right? Because it's hard to understand what this window is. It's a browser, right?
Yeah. So this is just a browser. This could be like Safari or whatever. I use a different browser. But this is the pipeline overview page. And so here we have a list of our pipelines. Once we run some pipelines, we get these nice visualizations and some, observability metrics. But in our pipelines overview page, it displays all of our, the pipelines that we've built. So I have 3 here. We're going to talk through each one of them. We're just going to start with like the simplest one to begin with. So if we click into that, we get to see a sort of a DAG of what's going on here. So these are each blocks in defined by Python. I'll open up the pipeline editor, which might be a little bit more familiar here because it's very similar to like a Jupyter notebook, right? And so you might be saying, okay, what's going on here? So we have 3 blocks. We're loading data from an API. So just a CSV really, but you could imagine this being any kind of API, anything you could write Python requests against. We also have templates for writing these to make them easier. You can write arbitrary Python, arbitrary SQL, anything really that you like. And then if you want to do more like data integration, we do have data integration pipelines as well. So that's like a 5-tran, right? It's built on Singer. So we have Singer connectors that could pull data from, pull data from MySQL and write to Postgres or something like that, right?
What's Singer?
Yeah, the Singer spec. Are you familiar?
Okay, I think Tom mentioned last time. This is some sort of open source connectors that allows you to pull data from one place and then put to some other place, right?
Yeah. So it's similar to Meltano, if you're familiar. I think Meltano is also built on the Singer spec, but they're a set of open source connectors. And so we just implemented those connectors within Mage, and it gives a standardized way of extracting and writing data. We're not using that here though. So this is more just writing Python. And then the one other thing that I want to call out before we get into this is that if I open up VS Code and I look at our container and you say, okay, well, Matt, I see you're doing all this stuff, right? But where does that live? It also lives as a Python file in our Mage project. So say, for example, you didn't want to use the GUI, or you wanted to move blocks around, or you wanted to bulk edit files, right? You can do all of that in your favorite code editor, and it's going to be reflected. And so I haven't actually tested this, but it'll be fun. It'll be reflected in Mage. In real time, I don't know. Let's find out. So we'll reload this. So there you go, right? So you can edit files in your code editor, you can edit them in the browser. It's all the same basically. So walking through this demo, this is our first cell here. We're going to pull data from an API and we're going to perform a test on that data in real time. I think that's one of the great things about Mage is that when I run this cell, it's fetching data from an API and then it's making sure that we have 1,000 rows. Hey, that's a software engineering best practice for bringing the data right out of the box, right? You should be able to make sure that your data is what you expect as you develop it. And we're shortening those feedback loops, right? And allowing you to build faster. So our data looks good here. And I think next we're just going to perform a really basic transformation. We're going to, do a little join here, clean up some of the columns, and then do another test on the data. So again, we can run that super quickly, see our transformed data. And then finally, the last type of block we have loaders, transformers, exporters, and custom types, of course, if you just want to write some other kind of Python. We have our Postgres database stood up in a Docker container, and we can just use a Postgres with config command here to write to the database. And we can do this using SQL as well. Mage also supports SQL blocks, which I believe I have later in my demo. But if we run this, we see that we can open a connection, export data, and then presumably I could also check to make sure it's been written. That data is then available in our data warehouse. Yep, there you go. So, super simple stuff, but I think the important thing is that we're bringing this structure to data pipelines. We're bringing structure to data transformation, and we're creating these components that you can reuse across every pipeline, edit as code, test, and really make sure that you're building a scalable data transformation system.
There's a question about tests. There are other questions too, but since you were talking about tests,
yeah,
I assume it's okay to interrupt you because it's relevant on topic to what you discuss. Can you tune the severity on those tests? Can you say that this test is super important, fail the entire pipeline, or this is more like, okay, just flag that it doesn't pass, but do not fail the pipeline?
That's a really good question. I believe that you can. I'll need to double check that after the presentation. I would have to check in our docs. But that's a really good question. I'm almost positive the answer is yes.
Mm-hmm. But the default behavior is the pipeline fails, right?
Well, let's see. Oh. So if I execute this with upstream blocks, we get a fail on the test row count and the pipeline fails. So yeah, if there aren't enough, if a test fails, it's going to fail the pipeline by default.
Mm-hmm. Yeah, thank you.
Yeah. Love the questions. Keep them coming. So this is a very simple pipeline in Mage. And one thing that we talked about, right, everybody's interested in DBT. Streaming is a pretty popular use case as well. So I do have another slightly more complex demo here that I'll talk through here, since there is a bit of a more complicated architecture. So next, we're going to talk about a streaming pipeline that lives within our dev container here that also uses...
sorry for interrupting you, because there is a question if it also supports SQL. Is your next demo shows how Mage, because I know it does,
yeah.
But I was just going to ask if the next demo will show that too.
I don't think it will exactly. So I think it would be useful to do that. So say for example, I wanted to write a SQL data exporter. This is what that might look like. So because I have a Postgres connection defined in my environment variables, I could just do the same thing here. And I think I wrote to public, I'll have to remind myself real quick, simple demo. So we can actually write SQL and select directly from that data frame, which is this transform block here. Mage is going to tell us what the name of that data frame is. And so this exporter now is designed to read from that data frame, perform a SQL operation, and then write it to a destination. So we could do really whatever we want here.
The destination here in this case is what?
Sorry?
In this case, I understand that the source is Postgres, but destination, what is destination?
The destination is Postgres. So I defined a data exporter.
Writes to Postgres.
To Postgres. It's actually, the source is this block, the previous block.
Got it. Got it.
Yeah. So here you can see this transform API block is being referenced as data frame 1. So what we're saying is, okay, like,
and the previous code.
Yeah. Let's take the output from the previous code, and then we want to write SQL and write it to our destination, because right, everybody knows Python's good for some things, it's not good for others. SQL is awesome for certain things, and others it's almost impossible. You need like 10 CTEs and 3 window functions, right? So this is an example where we can combine Python, we can combine SQL, and we can do some pretty cool stuff within the same pipeline.
It's pretty cool.
Thanks.
I think I interrupted you, so you will probably have to start the explanation for the next demo from
no, it's all right. It's all good. That's what it's about. So I like talking, and we're just having fun. So this next demo, we have living inside our Docker container. Something I didn't mention, right? We have a mock Kafka stream that's reading some sample taxi data, and we're passing that to a producer that's we're going to read with a streaming pipeline. So the idea here is, hey, everybody hears about streaming, right? Streaming is something that's like hard, it's ambiguous. Oh, like you hear about it. We only need real-time data pipelines, stuff like that, right? We're going to show you how simple that can be in Mage. And we're going to take our streaming data and write it to S3. And then concurrently, we'll have another pipeline, since everybody likes dbt as well. And we're going to read from that streaming data in real time and write it to Postgres. And so you could imagine if we just turned the dial on that batch pipeline, that dbt pipeline, and execute it every, like 5 minutes, 10 minutes, whatever you really want, it kind of becomes a real-time data pipeline, so long as our streaming pipeline is running as well. And so my goal here is to sort of show you the power of using a unified tool for this sort of data set, and how we can use something pretty tangible to create a near real-time data set that's close to something we might see in real life. And so the one thing I want to call out, you can pull this repo. You can replicate the entire thing. The one thing you do need to provide are S3 credentials or another cloud storage provider. That's the only piece that lives outside of this pipeline.
Can you zoom in? There is a request that it's not. Yeah.
Oh, sorry about that. Let's we'll go into slideshow mode here, and hopefully that's big enough. So we have our dev container, and we have a Docker. We have a Docker network living inside that dev container, and then within our Docker network, we have a Kafka and stream with our taxi data set that's being passed to a Python producer, and we're going to pick that up from our streaming pipeline, write it to S3, and then we have a separate pipeline that works as a batch pipeline and performs a dbt transformation, and then writes it to Postgres. And so, yeah, at any point, if this is not large enough, absolutely let me know, and we'll fix that. So we'll start with our streaming pipeline. Looks very similar to the batch pipeline. We just walked through.
In the same repo, right? So the repo is the same, the link that you shared, this QR code. This is in the same repo, right? So no need to clone another repo.
Exactly. So the repo, it just has one Mage instance that has all of these things available. So it should just be pretty simple. But if we're looking at, and the other thing I didn't show you is in Docker desktop, right? We have a Kafka container, and stream magic is just a Python file that creates a mock stream for us to read. So, we're reading from that local Kafka instance here, and it's pretty simple. We're just dropping in our configuration. And then we're going to we're not even really performing a transformation. It's just grabbing that JSON payload, and then we're exporting it to S3. And so I have an S3 bucket here. Well, it's in my other tab, I believe. I have an S3 bucket here with our taxi data stream, and that's going to receive the files that we're writing. So yeah, if I open Mage back up and I execute this pipeline, you see that right off the bat, it's going to start initializing the consumer and then start consuming messages. And so opening Docker quickly, if I go to Kafka, or rather, actually, I think it's in the other, DockerCon is sending me messages there. So you can see we're sending messages and flushing records from our producer, and that seems to be up to date. So if I go to Mage here, we should be reading messages at this point. Oh, wrong window. And there you go. So this pipeline is receiving messages. And I mentioned this is a taxi data set, so it's rides from New York City. But you can see that we're actively receiving messages and then ingesting those records up to S3. So defining this, all it really took was us to define our parameters, and Mage kind of handles the rest. It reads from the stream. You can perform some light transformation and then write to S3. And so if I wanted to look at, I actually have a sample of what one of these messages looks like. It's really simple. It's just like a taxi ride ID, point, have latitude, longitude, some like timestamps and statuses and things of that nature. So that's like part one, right? We read the streaming data, we wrote it to S3, but that's a raw data set. Maybe we go out and we do like some medallion architecture type stuff or process it in some way, but it's not really usable business data. So I'm going to stop this pipeline and we're going to talk about how we can turn that into usable business data with more of like an ELT type pipeline, and specifically using dbt, right? So this is the separate pipeline that I'm talking about. We're going into a batch pipeline. So we're just talking about streaming, and now this is a batch incremental pipeline.
So far, what we did is there is a stream with data, Kafka's stream, and there's a process that constantly is reading from that stream and puts data to S3. I assume in chunks, right? Like every minute.
Yeah. So and you can define the chunks, and you can define the format. And I didn't mention this, but we were writing to Parquet files in S3, and Parquet is a compressed, optimized file format for columnar operations. That makes some of this pretty quick and pretty easy. But that's exactly right. That's what we did. Yeah.
Okay.
Cool.
So I remember using Firehose for that, but it's so much easier.
Yeah. And I think that's the cool thing is that, streaming can be complex or it seems complicated. But at the end of the day, it's reading from a source and writing it to a sink. And Mage kind of makes that pretty evident. So now we have these files in S3, right? Like we have that bucket. And we can just write, since we can write arbitrary Python, you kind of have your choice of what library you want to use. It's like if you were using Airflow, but it's a little easier since we can just pip install this into Mage. So like in our requirements.txt file, we just include AWS Wrangler and then we can use it. So I'll kick this off and then we'll talk about what we're doing. So I have that bucket and that folder here that we're going to read from, just using the AWS Wrangler read Parquet. So there are actually a bunch of Parquet files in that directory. Like if we went to just to give you a little visualization, right? If we go into this directory, there are a ton of Parquet files. Some of these are older, some of them are newer. But read Parquet lets us just, I realize this also is probably pretty small. So there are a bunch of Parquet files, right? And read Parquet just lets us scan all of these and basically append them together to get a clean data set. And the next thing we're going to do is perform a couple tests. So we want to make sure that the columns are what we'd expect. And we want to make sure that the status column has the three values that we'd expect, which is en route, drop off, or pick up, right? They're taxis. They should be doing one of those three things. They're probably also like taking breaks, but that's not in our data set. So we can run this and you can see we get back our data set, which is pretty big. So we have, 500,000 columns. Or 500,000 rows rather, 9 columns, and both of our tests passed. So like that, we're ingesting, 500,000 row data set. We're running a couple of checks to make sure it has data that we'd expect, and we're bringing it into our Mage instance. And so this is where things get pretty interesting, I think. So I showed you how you could write SQL against a data frame before. Now the cool part is that you can also write DBT models in Mage that reference our data sets as a source. So if you're familiar with DBT, the DBT uses sources and references to access data. So sources are like well, exactly what the name suggests, source data sets. And so we can use this taxi data set to actually just the data frame from this previous block to run a DBT model on it. So if we wanted to select star, we're just going to select from that data frame. And we can execute arbitrary DBT models in our project. If you had like a macro that you like to use, you could pull it into a DBT block and run it right alongside Python, right alongside SQL. And you can see when I click run here, it's going to actually compile this query just to make sure that like it works and like this is all valid. So yeah, it's pretty powerful in the sense that you can bring in models directly into your pipeline. So that's one thing. That's a model. Maybe it's not the most useful. So let's talk about like an actual analytics use case, right? You have this streaming data set with taxi rides and different statuses. So some of you might be familiar with like the concept of a SCD type 2 table. I'll actually discuss what that is really quick. So like from the stance of I had a thing prepared where, you know, I was thinking about going through this where I did a whole like ask. Oh,
so for me, I understood type 2 and query as words separately, but together they don't make much sense.
All right. Well, yeah, no, we can talk about it. So if you're thinking about like when I say SCD type 2, that means slowly changing dimension type 2. If you look this up on Wikipedia, there's like an explanation. I don't think it's particularly good. All it means is that we're capturing a change log of data. So here's like a sample data set with first names, last names, phone numbers, start and end dates, right? And so you can see here, Mary Smith, you have a start date for her phone number, and then it changed in row 2 here to row 3. So instead of just deleting that row in red, we want to actually keep the record so that we know what the past looked like. But then below it, we just insert a new record, right? And so this is like the concept of an SCD type 2 table. Hey, we want a history of data, a change log of data with start and end dates. And if there is no if there is no end date, well, then that means that data is the most current. And so this is actually a really useful pattern for data analytics, right? Like analysts, if you wanted to say, hey, you know, like what was our total subscribers count as of this date? Well, you could have like a membership start and end dates, or maybe like what was our revenue as of this date? If you had like an SCD type 2 table with subscription prices, you could accurately track that over all time without needing to do terribly complex joins or crazy analytics. So at its core, it's very simple. It's just like a change log. However, it's often kind of complicated to build with a SQL. So we have this taxi data set, right? So we have raw taxi data. It's not telling us anything, but the question we might ask is, okay, maybe for a particular taxi, how long is it spending in each status, the statuses we talked about, which are like pick up, drop off, en route, right? Like we want to know how long the taxis are traveling. And if we like created a SCD type 2 table, well, then we probably could get some pretty good analytic insights out of that table. So this is just another DBT block that makes use of our taxi stream data set using full DBT, and then perform some basic SQL to generate an SCD type 2 table. And you know, I think what I'm going to show you today is really the power of DBT and the power of batch pipelines is that they allow us to go from execute and run they allow us to go from basically 0 to actionable insight in very few steps. So we're going to execute and run the upstream blocks here. And then we're going to build this model. And that should give us a SCD type 2 data set that allows us to query something actionable, right? So pass or test.
This tree view on the right side, and the things they are sequential, right? But can you have like more like a tree structure, like branches?
Yeah, that's a good call.
There's a question like, can you do conditional DBT runs? Like if a variable equals to that value, run this DBT job, or else like run this one. Is it something you can do with Mage?
It is, yeah. So we have the concept of a conditional block. And conditional blocks do exactly what you said, which are like if-else statements. So you can imagine having like load stream and then like an if-else, like maybe if tests fail, you know, do nothing. If tests pass, then execute this. So we could definitely do branching like that. These are just pretty simple pipelines for the purposes of this workshop, but I think it would be valuable to your point to maybe show something a little bit complex even.
Yeah, thanks.
Awesome. Yeah. And so, we have conditional blocks. We also have like dynamic blocks that do the same thing as like an Airflow dynamic task, right? They can like fan tasks out and execute them in parallel. So that's another pretty powerful data pattern. And so, basically, I think I want to execute the row. We're going to build the model. So just make sure. Sorry, it's a little tough on my screen because now things are getting tiny for me. But we executed the blocks before this, and then we built and executed this model. And you can see we print all of the DBT logs in the console, which can be useful. Like this is one way to run a pipeline. The other way I just want to make very clear is to actually trigger the pipeline. So like you take this and you schedule it, and then you'll get a trigger. You can also run it at once, schedule it, just like an orchestrator, just like other data transformation tools. And you'll be able to follow along with the logs there as well. So that's just important to mention. This isn't
There's
just
another question about parallel processing, and I think you answered that question already. That you can like generate many instances of the same task and run them in parallel, like in Airflow. You said something like that, right?
Yeah, we have dynamic tasks as well. So
tasks.
similar to an Airflow dynamic task, you can fan tasks out, you can execute them in parallel. And like if you wanted to do async like calls, we support Python, arbitrary Python, so you could do whatever.
Okay, thank you.
Sweet. So we executed this last DBT model. We had the output there. And now this is just a simple query to say like, okay, we just ran the model. Can we see what we got? And so this is the output here. And you might notice it looks very similar to what I just showed you. So we have a ride status, a start timestamp, and an end timestamp, as well as a duration. So we can see that the rider was, it looks like this is actually in reversed order. So we'll start from the bottom. The rider's picked up. It took about a minute to pick the rider up. They were en route for about what appears to be close to 20 minutes there, 12,000 seconds. Somebody else will have to check my math. And then they were dropped off at on 23/8/10. So going from this abstract, basically, right, going from this JSON payload, 500,000 rows of JSON, to an SED type 2 table that allows us to see exactly where a taxi was at a given timestamp and how long they were in each status. 2 pipelines, a little bit of code, and a little bit of DBT. So yeah, no, and I know, right, that's sort of the end of the demo that I prepared. I think it's a pretty powerful way of illustrating these things. But I also know that we have about 15 minutes left. So I want to take some time, maybe answer any questions anybody has. We could even just build more pipelines. Like I'm sure there are a ton of questions though.
So question from Daniel. Let's say I had 20 files, 15 small files, and 5 very large files. Could I run a conditional block to run 15 small in parallel and 5 large one at a time to avoid running out of memory and things like that?
Yeah, I think that would be possible. I think you just have to think a little bit about the logic, but you could do like, since I'm going to assume your files are in cloud storage, or I mean, they could even be stored locally. You could have a conditional block that says like, basically scan the directory and get the file size. And then fan those tasks out based on the file size. So, okay, we have 3 that are certain size, we execute that, and then we could loop back. Okay, now we have 2 bigger files. Now we want to load those into memory and execute those. I absolutely think you could do that.
Yeah, and then comment from James that an example would be nice. And I guess James is referring not to these 20 large files, 15 small and 5 very large, but more like conditional, like how can you do branching? If it's something quick, maybe you can show us.
I don't know. Okay, yeah. Okay, so
maybe like silly logic, like if something more than, I don't know, 1, then do that, else do the same thing.
Yeah, we can give it a we can give it a shot. I try to stay away from stuff like this in live demos, but you can
Okay.
see.
I,
I'll save that one for another time, and we'll come back to doing live conditional blocks because we only have 12 minutes, and I think that that would get
I see.
complicated quickly.
Okay. Well, let's say somebody is brave and wants to do this at home without supervision. Is there any link that
Yeah,
they will find?
absolutely, absolutely. And I fully encourage everyone to do everything out home without supervision. That's where you have the most fun. So if I were you, I would go to our docs, which I'm still working on. And if you have any feedback, you can also contribute to all of these docs. Uh, and you can look up conditional blocks. And so, we could walk through this together. We have 12 minutes, so maybe not enough time, but you create a new pipeline, you click on the button called conditionals, and you try to add a conditional block. And then in the block, you're going to define conditions. And then, so we have this conditional block that says like, if else, if you want to do this one thing, do X, otherwise do Y. And then we also want to look at dynamic blocks. So I would recommend conditional blocks and dynamic blocks, and the dynamic block can create multiple downstream blocks at runtime. They'll execute in parallel. So those two things, pretty powerful concepts, and I think they let you do everything that you're after. Yeah, and I'll send these links to you, Alexei, and we can get these resources out for people.
Did you add this illustration, or was it Tommy?
It was somebody. I think it was Tommy. Yeah, we like GIFs. We like
Looks
to make
like
things fun.
a Tommy thing.
Yeah, no, this is if you want to like have fun, go look around at our docs. You'll find all kinds of crazy stuff. So
Okay, well, let's see what else we got. What are the benefits of moving from Cloud Composer to Mage?
Google Cloud Composer.
That's like Airflow, hosted Airflow, right? Or
Okay.
what's that?
Yeah, that's what I thought. I just wanted to make sure because there's so many different names, right? There's like managed workflows, there's all this other stuff. Yeah, right. So like if we talk about also this GIF is just like a little distracting. While I love it, it can be distracting. So I won't keep that on the on the screen. So Google Cloud Composer is managed Airflow. So number one, the benefits are that you get access to all of Mage, which includes blocks, conditionals, like all of these pre-built assets and development frameworks for you to iterate more quickly. Whereas in Airflow, you'd probably have to build a lot of this stuff yourself. Maybe it's not as intuitive. You don't have a GUI. You don't have this user interface for editing, for collaborative editing that you do in Cloud Composer. And I would also say that deploying Mage specifically on GCP is very simple because you can run, I think Google Cloud Run lets you execute or launch Docker containers from an image. So we have a Docker image. You can just drop that in Google Cloud Run, and then you like have a Mage instance, like almost in like 2 minutes. It's actually pretty crazy. So advantages, right? Everything that we just talked about in Mage. Maybe if I want to be honest, Mage isn't for everyone, right? Maybe you really like Airflow. Maybe you have hundreds of DAGs built out. Maybe all your team knows Airflow and you're really comfortable with Airflow. And that's just something that you're dead set on. Your company is dead set on GCP, and you know that you're going to be in Google forever. Yeah, Cloud Composer might make sense. But if you're just getting started, if you really don't like Airflow, if you're looking for a simpler way to build pipelines, and you don't need all that added complexity, or you want a really beautiful user interface that lets you get stuff done faster and introduce less tech debt, I would highly recommend checking out Mage.
Mm-hmm. Yeah, thanks. Actually, I don't know, maybe you knew that this question was coming, but there is another question. How can Mage be hosted in Google Cloud Platform in production environments? And you said that you can deploy it in GCP in like 2 minutes by using Google Cloud Run. Maybe there is some documentation that shows how to do that? I'm sure there is documentation.
Yeah, so I did not know this. As much as I wish I could read minds, I cannot read minds. But if you go to our deploy documentation and then over to providers GCP, we have a bunch of really useful resources. We'll walk you through how to do everything. So this is the old guide where you'd have to push an image. Like there was a bit of a workaround, but now that GCP supports this like direct push, basically, we have a Terraform plan that you can just pretty much apply that'll run the Docker Mage instance in Google Cloud Run. So it's very straightforward. I've done this before. If you have any problems, like one of our biggest selling points, which I haven't mentioned so far, is that we have a really great Slack, and you can ask us questions at any time. We're super active. There are a ton, like everybody gets help there. So you can always just come ask us a question. But the deployment through Terraform, this Terraform template is very simple, using Google Cloud Run, and you can check that out in our docs.
Yeah, please send us the link to Slack. And I'm kind of disappointed that there is no animation in this doc.
We can't. There can't be animations in everything. We'll get there. We'll get there eventually.
Okay. And how much does it cost when you deploy like that? And on what? I guess the answer is it depends, right? But on which factors does it depend?
Yeah. So Mage is free, right? Mage is an open source project, so this is all free. The deployment's going to depend on the amount of compute you use and the amount of storage that you use, and that's largely a configuration thing. So if you run
Airflow, right? If you self-host Airflow, you will pay for compute, you will pay for what else? Like basically same things.
Yeah, I would say the cost is going to be close. It'll be very close to Airflow or any other tool that you self-host, but a lot less than dbt Cloud or Astronomer or anything like that. So,
okay. Will you offer Mage as PaaS? I don't know what PA. I guess it's platform as a service, right?
Potentially, that would be my assumption. In the future, potentially. Currently, we're just self-hosting, and any help that you need, you can reach out to us for Slack, and we'll help you for free. I think in the future that might be a possibility, but it might be a better question for Tommy right now.
I think in the last workshop there was a similar question, and there was also a question about being committed to open source licenses. And what I remember, Tommy said that the plan was to not do like these funny things like other open source companies do, like super limiting or removing existing options and making them paid. So that's not the plan.
Never going to be removing existing functionality. It's all about power-ups, right? So if we offer paid functionality, it's going to be like, wow, this thing takes it above and beyond what I would expect. So thanks.
Okay. Yeah, then another question from James is if you have public GitHub repo with example flows and pipelines, it would be nice to be able to see these examples and try to reproduce them.
Absolutely. Great question. So we have a ton of guides. We're working on consolidating them right now. Here's your image. So we have a bunch of quick starts, which we're working on improving. Actually, I'm working on improving. This is like most of my job is like writing documentation for y'all. But we have an ETL quick start in data integration. You can get up to speed with a lot of this stuff. And for some of these, we're starting to link out to those repos. So if, for example, I just rewrote the quick start on our main page. And one way you can get started is with a Docker Compose template, where you're just pulling a very similar repo to what we just used, but it's simpler. So you just run one command. If you have Docker and Git installed, it'll just run, spin up. You go to localhost and you can start developing, or you can open up VS Code and start developing. So tons of stuff on the docs. I would check out specifically the guides section, or just the quick start on the main page.
Okay, well, questions keep coming. How do you integrate documentation for your pipelines in Mage?
Sorry, could you repeat that? How do you integrate what exactly?
Documentation for your pipelines. I guess there are some pieces, for example, you want to describe what exactly is happening at each of the stages on each step of the pipeline. Maybe you want to write some documentation, is there a way to
for sure
that?
Yeah, I mean there are a couple different ways. I think if we're looking at the most common way, and I think that there's more that can be done with this. It's just you could write doc strings on the functions themselves, and we also have a way to generate those with AI. So it's possible to actually we have 4 minutes left, so and I don't think I have my OpenAI API key in this instance. So I'm not sure I can demo it for you just yet, but you can generate documentation from API for your pipelines, from using AI for your pipeline. So say you didn't want to go through and write doc strings, you could just like couple clicks generate it. Again, I would point you to our documentation on AI generated code here to learn about how you can write documentation using AI.
It's quite convenient, but it's editable, right? So AI writes documentation, but then you can change it, right?
Yes, as with everything. Hopefully, everything AI generates is editable. Yes.
Okay, good, good to know. So, question from Vibuff about your demo. When you were showing, in this example, when you were reading from a Kafka stream and writing to S3, and then processing stuff with dbt. How does Mage incrementally pick up files in the streaming use case?
So how does it incrementally pick up files? That's a good question. I think it's more maybe like engineering specific. So if you come onto our Slack, I would say go to Slack, ask us how the backend works for Kafka, and I promise I'll get you an answer there. I don't have that off the top of my head.
But the important thing is it does that incrementally, so you don't need to worry about that, right? And
Yes.
it's open source, right? So and actually, there's another question about your repo. So Mage is open source, and there is a GitHub repo with all the code. And the question is how to find it. So maybe you can show us where Mage lives.
Absolutely. So now that I'm zoomed in here, we'll make these slides available for everyone. I'm sure Alexi, right? But if you're in front of your computer right now, this left one here will take you directly to our GitHub, where you can star us. You can do whatever you want to do. The middle one you can connect with me on LinkedIn, and the right one is to clone our GitHub repo. So if you have your phone and you want to just take a screenshot or take a quick picture of that one on the left, or the URL is github.com/mage dash AI slash mage dash AI. So we'll share that out and make sure everybody has access.
Okay. Well, maybe last one, since we have a minute. Do you recommend keeping Mage up and running all the time, or do you recommend turning the containers on and off?
I mean, that's a good question. And I think it depends on your use case, right? Like, I hate to be the guy that just says it depends all the time. But, it kind of depends. If you're running pipelines once a day, like, does it make sense? Maybe you want to shut it down. If you're running pipelines every 5 minutes and you don't want to be launching from a cold start, like, yeah, it probably makes sense to keep it up. I think that's for your use case. And I think it would be nice to see some benchmarks on like the difference there. The difference is probably negligible since we're not like actively performing transformations or whatever. But yeah, I think you just have to weigh how often you're running pipelines versus what your startup times look like.
And I guess for the second demo, because it's a real-time example, a streaming example, you want to keep Mage up and running all the time, right?
Yeah, if you're streaming data, keep it up and running. Don't turn it off. The data will not stream. We're not that good. We can't stream data without the without the container running.
Right. And then the first example was more like a batch processing case, and like if it happens once per day, right? So there's no need to probably keep Mage running all the time.
Yeah, unless you want people to be able to edit code, right? Like if you want to have analysts writing and testing and debugging, like, hey, maybe you do want it up all the time.
So they don't need to host it locally. There is a central instance where they can just log in and experiment, right?
Exactly.
By the way, does it automatically synchronize with some Git repo? So let's say I'm an analyst and I prefer to work online in the browser, but maybe an engineer would rather clone the repo and work locally. Like, does it automatically, like, let's say I have an instance of Mage running remotely somewhere, and then an analyst edits the file and hits save? Would it automatically
absolutely, for sure. We have versioning. I'm not sure where it's at in the code. Yeah, you can run set up Git in the cloud, and then you have Git versioning. We also, independently from Git, have file versions just in case anything happens. Like if I want to go back to my my demo here. So I know we're getting close to time, but the answer to your question is yes, you can put it on Git and you can make sure that everything is version controlled. And then an extension of that is that, say that you're editing, like maybe in our DBT demo, we made a mistake. If I go to this pipeline here, I believe I can click. So if I go to actually, it's the specific file in a pipeline. I can click show versions, and then I get an entire version history of every change that I've made. And this is independent of Git. So not only can you version control your pipelines using Git, GitHub, all of that great stuff. If you just make a mistake, you don't have to like remember a bunch of Git commands. You can just go into Mage and find the file versions and then restore them.
And James says that he will likely follow up for these conditions.
Awesome. Well, love to hear from you, James. We'll get you a link to the Slack and our docs as well.
Okay, then we took 2 more minutes, but that was worth it. Thanks a lot, Matt, for joining us today, for doing these demos, and thanks everyone for joining us today and being very active. So I don't have anything to add. It was awesome. Thanks.
Awesome. Yeah, thanks. It was a pleasure.
Okay, well, then enjoy the rest of your day, the rest of your week, and we will probably have another workshop, because I remember we discussed it with Tommy that it's possible that we will have 3, so stay tuned. That's the second one. Anyways, yeah, it was nice.